BioAgents are transforming to be also scientific agents attached to a researcher, where a researcher is able to impart private knowledge, personal data, and improve that agent to be different from every other agent. And so the more technical and the more personal data that a researcher can give an agent, the better it's going to perform and better help both the people talking to it and creating scientific outcomes for the researcher.
I would say agent development is a really interesting place to be in right now, not just within science, but just overall within AI. You can think of these frontier language models as like a battery, and the battery's juice is intelligence. So these agents are a really interesting way of being able to use that intelligence. And so I think obviously you have the frontier labs like OpenAI, Anthropic, Google, working on these crazy models, but there's a ton of potential creative space that lies within agentic development. And I think we're all really excited about that at Bio. How do we build these scientific agents?
So over the past year, and especially in just the past 3 months, there's been an explosion of different teams, both nonprofits and companies that are building agents for science. You might call it called like AI for science, scientific agents. These are either chat platforms where the purpose is for researchers to chat with it and get specific help with research problems, because these chat interfaces have a deep understanding, or the way to look up a deep understanding of academic papers, do like literature review and breadth, or a very concise deep search, and they have some knowledge of maybe specific like genomic modeling and like the actual calculations to do that a model like O3, which is a foundational model, can't perform. And so we're seeing a growth of these models, but also experiments in the chat interfaces and actually how people will talk to them. The difference between what we're calling an on-chain agent or a Web3 agent is that because the agent has access to a wallet and can sign either attestations, they can send and receive tokens, it has a lot more powerful capabilities that are a little bit uncharted, but it's matching the growth of how blockchain is becoming embedded in so many different parts of the world. Stablecoins are becoming ubiquitous, and by keeping agents, these scientific agents, by giving them wallets, and they're able to keep up with the growth of blockchain.
I guess one way to think of a blockchain to begin with is a blockchain is almost like an open, global, permissionless database. In many ways, this is exactly what a blockchain is. And I think a decentralized knowledge graph is just a way of structuring knowledge, whether that's like previous knowledge and you add it to a decentralized knowledge graph, or new knowledge. You can basically think of a DKG, decentralized knowledge graph, as a living and breathing dynamic system. And I think this is one of the key differentiators, I would say, about Web3 scientific agents versus Web2 ones. In a Web2 environment, you're only going to be successful if you have some competitive advantage, but it's also so hard to compete with the open source. I mean, 99% of the internet is built off of open source software, even if maybe 1% of companies or 1% of the code is capturing a lot of the value. I mean, the utility is really in the open source.
I would add to that the DKGs, like decentralized knowledge graphs, when you have a fleet of AIs all contributing to a knowledge graph, that knowledge graph can grow insanely fast. And with these new models, they can actually be doing in silico experiments, they can be receiving results, and each of those pieces of data can be added to the knowledge graph, and enough of them combined can be possibly turned into a paper. You run statistical analysis, whether it's worth sharing those results. And when you can share those results, then it's a better improvement over the old like patent office system where you'd have to wait days, weeks, very long time to patent something. You can add to the decentralized knowledge graph, other people can see it, and you receive credit and possibly tokens for the work that you're doing or that the AI is doing. And so it's a much faster system, and the throughput of thought of these agents is increasing, and we have to have new systems to give credit where credit's due and reward both the agents and the owners of those agents.
I think the idea that everyone has to launch their own decentralized knowledge graph might not necessarily hold true. I think there will be like just generally open scientific knowledge, decentralized scientific knowledge graphs that people can build off of. For example, it's like reading a Wikipedia article. You don't need to like launch your own version of Wikipedia. You can kind of leverage the existing Wikipedia. I think you'll have different like entities, different elements within these decentralized knowledge graphs. For example, papers, preprints, handwritten notes, podcasts, or whatnot. Add those to decentralized knowledge graph, and then arm an agent with access to these decentralized knowledge graphs, allow them to potentially propose hypotheses, maybe attest that this is a hypothesis that they've proposed, and create a proof of invention, attestation that this is where the intellectual property originated from. And then you'll have maybe the BioDAOs or even the BioAgents themselves vote on which scientific hypotheses and paths of inquiry to pursue. I think this idea that the decentralized knowledge graph is the agent's interface is one that has been making a lot of sense for myself.
Here at DeSci Berlin, there's a presentation about Aubrey, which is an agent based on Aubrey de Grey, and any scientist really can either think about this in terms of top down, where the scientist creates an agent that imparts some special knowledge to the agent. It could be private lab notebooks, emails. It basically differentiates that agent from every other agent, and many more people in the world can talk to that agent, and either if they're an expert in the field of longevity or neuroscience, more of the world can benefit from that scientist's knowledge or that scientist's lab and research. And so that would be a valuable service. And then conversely, the more bottom-up approach is that the labs can make their agents available, and any person from the thousands of college labs or pharma companies out there can actually interact with that agent, and everyone has their own specific problem and their own specific interest and research areas. And so there's more moments of serendipity that are possible when, say, Aubrey de Grey's agent can make notes about what Aubrey is working on and actually crowdsource information and build up this knowledge graph over time, because much more of the world is looking at it and interacting with it than a single lab.
Yeah, this idea of scaling up scientists is super interesting. It's we've all had a teacher that really resonated with us in the past, and maybe most other teachers did not. But if you could replicate that single teacher across the entirety of your education, that would be fantastic. I think being able to scale up prominent scientists like Aubrey de Grey and other key opinion leaders in the scientific community will empower those that might not have access to these scientists to be able to potentially discover what is that new sort of area that has not been discovered yet. How do we sort of influence the serendipity? How do we accelerate cross-pollination of ideas? I think that is super cool, being able to scale up scientists.
A lot of ideas are found between the border of disciplines, so interdisciplinary science. And so if one expert has lunch with another expert and they talk for an hour, and there's almost always some fruitful ideas or research directions that could come from that. What we're talking about is having an agent based on an expert and having another agent, and you can put them in a hypothetical room, or actually have them converse in there's a famous example of Discord backrooms, the infinite backrooms of an agent called Truth Terminal, where those are just foundational models talking for months, and all these crazy ideas, new memes, dialogues, conversations, humor, all was generated from these AIs talking to each other. And there's something unexplored where scientific agents can talk to other scientific agents, and you run them in a long-running conversation and just generate ideas from interdisciplinary experts.
I mean, it's like a scientific conference is a meeting of the minds. Like you can have millions or billions of these conferences like in parallel. It's going to be a crazy like water faucet for scientific hypotheses, I feel.
Yeah, and because they're connected with a wallet and they have tokens to spend, and BioDAOs can fund these micro proposals, just a good idea doesn't need to wait. You can just run it and see the results, and then the conference doesn't just end in conversation. There's actual papers that could come out of these. Actually,
I'm most excited too about being able to go from the scientific hypothesis directly into in silico validation. This is, I guess, my background was in running a lot of computational biology models. I feel like this in silico validation piece still has yet to be borne out in a lot of ways, where maybe these models, the quality of their outputs hasn't been quite up to par. But I think once you can get to that in silico validation, you're more likely to succeed when it comes to going into the wet lab, like preclinical research to clinical research, for example. That's going to be a crazy world. Oftentimes you'll hear that researchers do not have a problem of a lack of hypotheses. You know, there's too many hypotheses, but they don't have enough bandwidth, whether that's financial bandwidth or maybe just straight up time bandwidth. I think by leveraging agents, like you can have like these hypotheses that are not necessarily pursued maybe by the original scientists, but they can be pursued elsewhere. And I think having a tokenization of an agent allows the like a percentage of any value captured, maybe be it by like intellectual property or whatnot, to go back to that original agent. And it's basically like scaling up the scientists the same way you would scale up compute instances.
And on the patient side of it, I think similar to what we were talking about earlier, where it's a greater surface area for people to talk to the expert that they want to talk to. And so if these agents are representing a scientist or a researcher that has like an actual product where the patient is curious about either advice, medical advice, or like buying that product, that therapy, it can basically be a form of onboarding for any sort of therapeutic product where more people can talk to the agent, get the help they need, and go on with their lives.
Yeah, actually this patient perspective is a really interesting one. I've been speaking to some of the BioDAO communities that we're working with, and there's a real demand for these like telemedicine agents. And I think not just from like the patient research side, but just the patient service side, there's a ton of value that these agents can provide. Like maybe we, for legal reasons, cannot call it medical advice, but it's better than having nothing or better than having uninformed advice. So yeah, I think there's tremendous potential here too.
Yeah, so like every BioDAO has a community, and especially for some like Curetopia, where it's about rare diseases, like every person has anecdotal evidence or anecdotal data that they want to share with the agent. And in aggregate, it's very important to share that and make it easily available for people to talk to it. And the agent can be collecting that data, sharing with the research team, and sourcing either an experiment and help back to that patient. So decentralized knowledge graph is decentralized because it's an open, really like an open source node, really just an open source table, if you want to simplify it, where anyone can download it and view it. But it's about editing it where the tokens come into play. You basically need access rights to edit it, and you need your edit to be confirmed by the rest of the network. And so there's rules that we're making that will determine how an agent can interface and like how an agent can add to the knowledge graph or edit it. That can be both based on the quality of its input, so like the quality of what it's trying to add, which can be judged by humans or another AI, as well as their like a token threshold where they could either have a minimum number of tokens to be part of this BioAgent community, really, yeah, either a certain number of tokens or staking a certain number of tokens. And in return for that, the knowledge that they add to the knowledge graph should be able to be used by others, and they're rewarded for that addition.
I think one really interesting application is the classic Isaac Newton quote, like, if I've only seen further, it's by standing on the shoulders of giants. If you're able to create a system via the decentralized knowledge graph that people are willing to share data, ideally the sort of proof of like people trying to build off of your work should it should play out. And I think if you're providing like poor data to the decentralized knowledge graph, first of all, there's I think a lot of ways to prevent this, and there's a lot of companies working on this, I believe. But you can't really further a hypothesis off of a house of cards. And so if you think about the knowledge graph building off of itself, it will like a specific branch of that graph will collapse if it's not like solidified. I guess maybe that's the right word, solidified. So maybe being able to build systems where the branch, almost like the height of the branch, is further rewarded. I think Vitalik has talked about this with like deep funding, right?
Yeah, I was going to bring that up, where this BioAgents can be thought of as meant to increase the speed that we grow the web of knowledge and increase the accessibility of the web of knowledge. And so these agents are almost working with like tech trees, where they're building off nodes in the knowledge graph that were already there and adding to it and expanding it. And there's no one yet has even come close to solving this problem of correctly incentivizing scientific work and like a kind of a trickle-down stream of income for scientists that'd be completely different from the patent system. But it's becoming possible where you can have impartial AIs judging the work, which is what Vitalik did with deep funding and other experiments with like correctly attributing a code base. Like the package manager of a code base actually has parallels to like the scientific web of knowledge, where if you have not a human observer, but an impartial AI observer, you can trust it to be fair and to correctly assign value to this web of knowledge, and it's an interesting experiment for sure. In the next 3 to 6 months, as we start to launch many more BioAgents, they're going to, I think one of the key things to do is give them the tools to, as you said, like interact with the in silico testing suites, even like in vivo or these cloud labs that can do wet lab testing. So I see it as helping with the problem of reproduction and replication of these studies, where because it's actually just like API requests to these in silico or cloud labs, we can actually reproduce those exact API requests and receive multiple, almost like audit them at once and receive multiple results. Mm-hmm. And I think that'll help with the scientific process, because people can see that and see that exact API request that returned similar results from multiple labs, and then a paper can be written, then like a therapeutic drug can be developed.
Yeah.
And
I think the reproducibility one is huge. Like if you're able to send like these to multiple cloud labs, for example, that's huge. I would also say that these tools are like a canvas in many ways. The same way, like, ChatGPT completely changed the world. I think we just need to put these tools in the hands of motivated users and see what they come out of it. Like, we have a ton of hypotheses for what they'll do, but I think the benefit that we have at Bio is that we have such a diverse community from like a variety of professions, geographic areas, educations and whatnot. And I'm really excited to see like the diversity of use cases as well.
So many different scientists would create an agent based on their work, I think. They use Bio to scale it. The Bio token would be part of how that scientist can make an income from this agent that they empower with their knowledge and let the world talk to. And the scientist benefits, but also all the other researchers that interested in that scientist's work would benefit as well. There's a Web2 explosion of scientific agents that like Google co-scientists, Future House, there's a ton of projects out there that experiment with Web2 scientific agents. I guess they don't call it Web2 scientific agents, they just call it scientific agents, but here in the blockchain world, we're Web3, and so we believe that these capabilities add like extra functionality to the agents that are going to be incredibly important in achieving their widespread use and achieving like the impartiality to how they're used and more open access to the data that the scientific agents are using. So like we'll interface with them where some of them have APIs that are available, such as the Future House Robin API. Some of them have code bases that are open source, and so we're grabbing like really cool parts of it out, such as like bioML from Stanford, and we're able to use them and improve our agents. And then with the wallet side, because they go through the launchpad, the bio launchpad, and because they have a treasury, they're able to have extra power in the world that a scientific agent without access to tokens, without access to money, doesn't have.
I think there's an interesting opportunity for scientists to create their own scientific agents because through tokenization, maybe the scientist owns like 10 to 20% of the overall token supply of this agent. If anybody across the world or even any other agent uses that scientific agent to come up with some IP, some of that value is going to accrue back to the original scientist, like a much larger percentage. The same way a founder of a startup ends up with a lot of equity, you'll have scientists with a lot of the potential income streams that might have, some of the income streams that might have been created based off of interesting research that led to commercialization.
In the blockchain space, there's been the idea of personal tokens that have never really taken off, but like Coinbase and like the base slogan now is like to coin everything. And what we're building is a way to safely store a scientist's knowledge. And when it's not just leaking their data sets to the world, but it's actually training an agent based on their personal data set, some private info that gives the agent some secret sauce and some extra ability to make the correct decisions in that field of the scientist's work. Mm-hmm. And so by creating a scientific agent, there's a token attached, and the scientist can monetarily profit off the agent. If the scientist is doing good work, people can notice the scientist, people can interact with that agent and add some virality to the scientist's work beyond just publishing papers and getting to journals. It's like a new way of actually showing that your work is real and your work is out there, and getting other scientists to both learn from you, but also add to it in the case of the DKG.